Now, a researcher measures blood pressure on the same patients before and after treatment. Which test should be used? We use paired t-test. Now, let us see the in-depth explanation for that. So, because the same individuals are measured twice, right? The observation before and after a pair after are paired and are not independent. They are dependent. So the correct approach models the within subject differences. So the paired t-test computes the mean of differences, that is xi after minus xi before, and tests whether that mean differs from 0 using the t-statistic d upon s d upon 210, where sd is the sample standard deviation of differences. One way ANOVA and independent t-test assume independent groups. One way ANOVA and independent t-test assume independent groups, and chi-square is for categorical counts. Now, a 95% confidence interval for mu1 minus mu2 is minus 0.5 to plus 0.5. So the null hypothesis cannot be rejected because at alpha is equal to 0.05, the interval contains 0. So 95% confidence interval gives a range of values that are compatible with the data under the model. If the null values 0 lies inside the interval, the two-sided test at alpha is equal to 0.05 would not reject H0, H0. Now CLT approaches basically for a large enough population size n, the sampling distribution of the sample mean will approach a normal distribution regardless of the population's original distribution. So the CLT states that the sampling distribution of sample mean tends towards the normal distribution as sample size n tends to infinity. For a wide class of underlying distributions, this is why normal theory inference often works even for non-normal data once n becomes sufficiently large and other options are incorrect or mistake CLT properties. Now PCA reduces dimensionality by keeping components with highest variance. So PCA rotates the feature axis to the orthogonal directions, principal components that successfully maximize the variance. Dimensionality reduction is achieved by selecting the top k principal components that capture most variance. So PCA does not explicitly remove noise features, right? It forms linear combinations of original features. Now, agentic implies the system can act autonomously in pursuit of goals, perceiving environment, making decisions, planning, and taking actions with some degree of independence. Access to data, computation, or simple yes-no answering are not sufficient. Autonomy with goal-directed behavior and capacity to act is a core property of an agentic AI. Right, moving on. So when is lasso regression particularly useful? When we have many correlated features and want to perform variable selection automatically. So lasso yields sparse solutions and is commonly used when p is large relative to n, or when we expect many irrelevant predictors and want automatic variable or feature selection. Caveat is with strongly correlated predictors, lasso can randomly select among them. Right now, TSNE is basically stochastic. Results may vary across runs and depend on perplexity. TSNE uses random initialization and a stochastic optimization, gradient descent. So embeddings can vary between runs. It also is used for nonlinear data, and perplexity is a crucial hyperparameter controlling effective neighborhood size, and thus cluster granularity. TSNE does not preserve global geometry, nor is it deterministic by default. Right, now moving on. So why interpret TSNE clusters cautiously? So clusters may appear well separated even if original data lacks clear representation. So it emphasizes local neighborhood structure and can artificially exaggerate cluster separation, making noise look like discrete groups. It is non-linear and non-parametric. Distances and global geometry in low-dimensional embedding are not reliable indicators of true high-dimension separations. Right, now moving on. So these are basically just some questions which we have already covered. So we can skip this. Right, let's go through one of these. So a drug dosing agentic AI is deployed to optimize medication schedules, discuss potential unintended consequences and strategies to monitor them, and what safety measures can be incorporated to prevent their harmful use in hospitals. So deploying an agentic AI that autonomously optimizes medication schedules introduces benefits like personalized dosing, adherence optimization, but also potential unintended harms. Unintended consequences include inappropriate dosing due to model errors or dataset bias, for example, underrepresentation of elderly or patients with renal impairment, reward hacking when the agent optimizes surrogate objectives that correlate poorly with patient safety, lack of robustness to rare clinical contexts, over-reliance by clinicians leading to de-skilling. And to monitor these risks, systems should log every recommendation and action, track override rates and clinician acceptance, and implement real-time anomaly detection and drift monitoring to detect distributional shifts in input features or outcomes. Safety measures should include hard clinical constraints like absolute dose limits, contraindication checks, human-in-the-loop workflows. High-risk changes require clinician approval, and conservative initial deployment in shadow mode. System runs in the background collecting recommendations without acting. Staged rollouts with pre-specified stopping rules, and thorough prospective clinical validation before full automation. Then transparent explainability, showing the features and historical data supporting a decision, provenance linking to source data, labs and allergies, and regulatory compliance, that is, clinical governance, institutional review, and legal frameworks are essential. Finally, emergency kill switch capability and routine safety audits plus continual retraining and calibration with up-to-date data mitigate long-term alignment drift. And then other questions, long answer type questions, you can go through. Right, I'm pausing this on the screen so you can pause and take a screenshot or basically read through it. This is the second question here for the Bayes rule, and this is our first question. So that's it.